you can tell me what characterizes a geometric sequence. How do I know that I'm working with a geometric sequence? What are its characteristics? And again, you are more than welcome to unmute yourselves because we are a relatively small group. But what is a geometric sequence? Anyone? Okay. Well, a geometric sequence is one that has what we call a constant ratio. Basically, what that means is to get from one term to the next, I'm going to multiply or divide by the same value each time. Generally, we are multiplying. And so we're either multiplying by a fraction or by a whole number. But when we are working with geometric sequences or series, we'll get to series, like I say, what we are looking out for is this constant ratio. Now, this constant ratio can be found depending on the information you have, but is generally found by taking term 2 and dividing that by term 1. But you could also have term 3 divided by term 2, term 4 divided by term 3, etc., etc., etc. So basically what you're doing is you're taking two consecutive terms and you're finding what the ratio is between those terms. If you can do that and that ratio is then constant, what you have is a geometric number pattern or geometric sequence. Alright, so what we're going to have a look at today is exploring this, looking at the first formula for geometric sequences, how to use it, and just some basic things that we always need to remember when we start working with these sequences. Because what you're going to see is that the formula that we use deals with an exponent. And so we have to remember some of our exponent rules from like grade 8 and grade 9 in order to deal with this stuff. All right, but let's have a look. So if we just have a look at this very first basic example, what I'll actually do is I'll do that. We are going to identify just what's going on in this pattern. We don't need to find general terms yet, nth terms, nothing like that. We just want to see how can I identify or how am I able to see that a pattern or a sequence is actually geometric. Okay, so what I have here is 3, 12, 48, 92. I'm definitely not adding a constant difference, so it's definitely not arithmetic. Okay, I know that because if I work out my differences, they're not going to be constant. If you go a step further and you go and try and work out what your second differences are, you're going to see that you also don't have a second constant difference or constant second difference. And so what that means is it's not going to be quadratic. So we only have, in terms of what we know, geometric patterns left that we could potentially have here. So I want to talk about this ratio really quickly. So remember, this is term 1, term 2, term 3, and term 4. And what we want to check for is, like I say, whether or not these ratios are constant. So if I took term 2 and I divided it by term 1, that would be 12 divided by 3, which we know is 4. If I did the same thing now with term 3 divided by term 2, that would be 48 divided by 12, which is 4. And if I did term 4 divided by term 3, I would have 192 divided by 48, which you might need to use a calculator for, which is absolutely fine. But either way, you get 4. And so what I want you to see here is that any time you are finding the ratio between consecutive terms, that ratio is always constant. And so that is my defining characteristic of a geometric number pattern or a geometric sequence. And so when we have these constant ratios, that's what I'm working with. Now that constant ratio is going to come into our formula that we're going to use for geometric sequences, which we'll chat about now in a second. But you have to be able to find the constant ratio. And then, like I say, it will be used in the formulas that are associated with this type of number pattern. So again, this is on your formula sheet. This is not something you have to learn off by heart. If we want the nth term or the general term of a geometric number pattern, Our formula is a times r to the power n minus 1. Right, now Tn and n stay exactly the same for all number patterns. So Tn in quadratic, arithmetic, geometric all means the value of a term. N in quadratic, arithmetic, geometric all means the position of the term. Now, we saw an a in quadratic number patterns, but we spoke about the fact that that a is not the first term, it is just the coefficient of your n squared. Whereas with arithmetic patterns or arithmetic sequences, the a in Tn equals a plus n minus 1d, and that a represents your first term. And that is the same for your geometric patterns. So if we just have a quick reminder for ourselves of what each of these things mean, a is your first term of the whole sequence that you're working with. And now because we're working with a geometric number pattern or geometric sequence, r is our constant ratio. And that's why it's so important to know how to work out your ratio, because you may potentially need it in order to work out your nth term. So we need to know those two bits of information in order to find the nth term of any geometric number pattern. All right, I'm going to write the formula down again as we start to look at some examples. But let's jump into some examples. I'll leave that up for a second in case anyone wants a screenshot. Otherwise, like I say, let's have a look at how we actually deal with these geometric number patterns. So I'm just waiting for everyone to take a screenshot if they'd like to. But I'm going to move on fairly quickly, because this is just some general information. Obviously, the important stuff is our examples. All right, so let's have a look. Consider the geometric sequence 2, 6, 18, etc., etc. So there's two questions here that we have to answer. We'll get to them in time. But the first thing, and I say this every single time we've looked at an example in terms of number patterns or in terms of sequences, the first thing that we always do is, because we've been told it's a geometric sequence, in this case, we're going to work out what our constant ratio is. If I told you it was arithmetic, you would go and work out what your constant difference is. If I told you it was quadratic, you would go and work out your first differences and then your second differences. It is just so helpful to have all of that stuff done already, because it's going to help you answer questions around the nth term. Okay, so this can all be part of your working out when asked to determine the general term. You don't have to do it separately, so I'm going to do it as part of my working out. But I need to know what r is. Now remember, I need to know what r is, because in order for me to find Tn, I need a, which I have, but I also need r. Those are the two bits of information that we said we need. In order to work out r, can someone remind me how I work out my constant ratio? Again, feel free to unmute if you want, or you can put it in the chat. How do I work out r?
Hi, ma'am.
Hi.
Okay, ma'am, can I try, ma'am?
Yes, I'm ready.
So I think, ma'am, if you find R, you're gonna have to use like T2 and T2 over T1.
Nice. Like that.
Yes, ma'am.
Perfect. Is it Truma?
Yes, ma'am.
Awesome. Thank you so much. Okay, do you want to carry on? Do you
Pleasure,
actually
ma'am.
want to go and substitute in the values?
I'll substitute, ma'am.
Okay. All right, so guys, exactly. We go and substitute now, and your ratio is exactly that, T2 over T1. If for whatever reason you felt you wanted to say T3 over T2, no issues there. By all means, do it. As long as you're dividing the term in front by the term just before it, you're going to get it. So term 2 here is 6. Term 1 is 2, which means that my constant ratio is 3. Now we can see that if we go back to our number pattern here, if I take 2 and I times it by 3, I get 6. If I take 6 and I times it by 3, I get 18. So we can see that my constant ratio that we've worked out is correct, because I am actually getting the sequence I was given. Alrighty, but now we actually want to go and work out what Tn is. So Tn is equal to A, which in this case is 2, times R, which we've just worked out to be 3, to the power n minus 1. Now that's it, guys. There's absolutely nothing else you need to do. So finding Tn for a geometric sequence is actually really nice. It's not like your quadratic where you've got 3 equations that you need to solve. It's not like the arithmetic where we sort of feel like we have to simplify. That's it. Sub an A, sub an R, you are done. If you want to, because sometimes it is quite useful, you could write your A value in brackets and then have your R value in brackets to the power n minus 1. It makes absolutely no difference because remember, both the dot and the 2 brackets next to each other mean multiplication. It's entirely up to you. The brackets are useful if you have fractions or if there's negatives involved, but we'll get to examples like that. So how you choose to write it, completely up to you. But either way, we have worked out that Tn, or our nth term, is 2 times 3 to the power n minus 1. So really the only thing you might have to do, or might be asked or expected to do, is find out what your R value is, but that's nice and easy. And as Chuma said, it's literally term 2 divided by term 1. That's it. Right, if we have a look at our second example here, we've been asked to determine the value of the 8th term. So can someone tell me what value or which variable would I now replace with 8? Which variable have I now been given the value of in order to substitute to find the 8th term? So remember, we've got Tn and we've got n. Is the 8th term telling me what n is, or is it telling me what Tn is? Nice, Morgan. Alrighty. So exactly, please remember, anytime I give you a position, because remember that is what n represents. N is a position. Anytime I give you a position, 1st, 2nd, 8th, 27th, whatever, that is what you substitute in place of n. So this is now n equals 8. And so all we do is we sub it in. Now guys, remember T8, or the value of term 8, is our notation. That's how we indicate that we're working out the value of term 8. And now we just sub in. So 2 to the power 3, 2 times 3 to the power 8 minus 1. Now again, great tools, if you know that 8 minus 1 is 7, you are obviously welcome to say to the power of 7. You can simplify that quite easily if you would like to. You don't have to. It is completely up to you. But now that you've got all your values substituted, you just chuck that into your calculator. I'll give you guys a second. You can unmute yourself. You can put it on the chat. What is the value of term 8 in this sequence? Once you've substituted that all in, what is your value? Nice, Morgan. Nice, Michelle. And Tori, so nice. Just making sure I'm reading my numbers correctly. Good. Okay, exactly. 4,374. And again, that's it. So geometric sequences are actually quite nice just in terms of like the basic questions we ask you. Finding R is quite easy. The substitution to the formula, nice and easy because we don't actually need to simplify. And if I ask you, say now for the value of a term, also nice and easy. Things obviously start to ramp up, and especially because this is matric, there are a few add-ons that we now start to add to it, but the basics of geometrics really, really aren't tricky. And so if we can get those basics, we should be good when it gets to the harder questions. All right, so I'm going to stop there in case anyone needs to screenshot. There's going to be a you try question coming up now. If you guys are new, I give you 2 options. There's an easy option and there's a medium option. You decide. Okay, if you're not feeling super comfortable, choose the easy one. If you are feeling super good, choose the medium one. They both essentially are the same question. One is just slightly trickier, whether it's because of values or whatever. But you decide where you're at. I'm going to show you both answers. You're going to be able to screenshot both. So whichever one you choose not to do, you've got the other one, or you've got that one then as a practice example that you can go back to. Alrighty, so here are your you try examples. Again, you've got easy and you've got medium. You decide which one you want to do. And there's 2 questions for each. Determine the general term or the nth term, as well as determine the value of one of the terms. For each of them, it's different. You decide which one you'd like to try, either the easy one or the harder one, and give it a go. I just do want to make clear, grade 12s. This is the term 4.5, and this is the term 6.25. So those are terms. Remember, our terms are separated by semicolons, not commas. So just be mindful of that for the easy one. If you would prefer to write it as fractions, I can. So that'd be 2, 3, 9/2, and 25/4. So if you prefer to write it out as fractions, that's also absolutely fine. Just don't get confused between, excuse me, the comma and the semicolon. Right, I'm going to stop talking so that I don't disturb you. If you have questions, you're welcome to put them in the chat, or you can just unmute yourself and ask. But let's go. I think 5 minutes should be enough. I'll check in a few. Feel free to also put answers on the chat as you go along. It might help someone else. If you're done, you can have a little stretch break. We don't do a lot of brain breaks in grade 12, unfortunately. So do take time to move, make sure you're happy. Guys, when you're done, just give me a thumbs up so that I know who is done and who just needs a little bit more time. Either one is absolutely fine, but just give me a thumbs up when you're done with your chosen question. Thank you, Mitchell. All right, so guys, just generally, there was a question that came through. Generally speaking, when rounding off, it's always to 2 decimal places, unless the question specifically tells you otherwise. So what you see is in like that general information before a test or an exam, it's usually on the front page or just after the cover page. There'll be instructions like, I don't know, write your name, answer on the answer sheet, whatever. And then in there it says where, unless otherwise stated, round off to 2 decimal places. So just always assume 2 decimal places. If they want you to do something else, it will say so in the specific question, and then you do what the question tells you to do. So always 2 decimals. Nice, guys, you're going at a good pace. And I don't see any questions as of yet, so that's awesome. But obviously ask if you do have any. I think a few people are still busy, so I'm just going to give you another minute or two. And then don't forget to screenshot when I do show the answers, because like I say, you then have an extra question for practice if you need. Amazing, grade 12s, awesome. Right, let's have a see. Okay, so if you did the easy one, here are your answers. So remember, you are looking for the general or the nth term of the sequence, which means you have to know what the ratio is. You know what A is because I've given you the sequence. So you work out your ratio, sub it in, done. Nothing more that you need to do. I then asked you for the 15th term of the sequence. Again, n is equal to 15. You substitute it in and you solve. So there it was 583. And there, this is the question, 2 decimal places, comma, 86. Right, if you did the slightly trickier question, with just a few fractions involved, and sometimes fractions freak us out. I gave my grade 10s a fraction question today, and I've never heard so much complaining in my life. So fractions freak us out, and that's okay, but we do need to be able to deal with it. So here, your common ratio was 1.5 or 3/2. Your first term was a half, sub it in, got your value, or got your general term, done. Same thing when you want to find the 19th term, sub in 19 for n, get your answer, done. And again to 2 decimal places. All right, the only thing I am going to just point out, and it probably seems like such a silly thing to point out, but just remember that if you have got fractions as part of your terms in your sequence, when you find your ratio, you are going to have a fraction divided by a fraction. Obviously, you would just type that into your calculator. But if for whatever reason, it probably wouldn't, but just if for whatever reason it said without a calculator, remember when we divide fractions, we tip in times. And so what you would need to do is change that to multiplication, multiply your numerators, multiply your denominators, and that then simplifies to 3/2. It is highly unlikely they would ask you to do that without a calculator. I'm just in case, just as a reminder, it's always good to be reminded of these little things that we learned in junior maths, and now that we're in matric, we often forget the basics.
Sorry, ma'am.
Probably never. Yeah, sorry.
I think I'm having a problem, ma'am, with like the medium. So like I put like the fraction, like I said, like a fraction on top of another fraction, and like I think
Okay.
I got something totally different from the R you
So
got, ma'am.
did you say 3/4 over 1/2 like that
Yes, ma'am.
on your calculator?
Yes, ma'am.
Okay, let us double check that situation. Let me grab a calculator. Hannah? All right, so I just want to share my calculator with you, otherwise it's completely pointless what I'm about to do. Okay, so you all should be able to see the calculator on the screen. If you do that, let's hope this works. We're going to have a fraction and a fraction, so 3/4 over, and then another fraction, 1/2. You still get 3/2. So just make sure you've typed it into your calculator correctly, Trimmer.
Yes, ma'am.
Okay, cool. Okay, so guys, that's also absolutely fine to do the fractions within fractions because you are just going to use a calculator. There's absolutely nothing wrong with that. Don't know, for some reason it's just not something that my brain thinks of, but you are more than welcome to. There is nothing wrong with that. All right, so there is the two answers. I would take a screenshot just in case you don't have all the information, but let's take a screenshot there, get what we need, and then let's have a look at our next question. Okay, so guys, what you will notice is I didn't ask a question where I said which value or which term in the sequence will have a value of this number, okay? And in the arithmetic lessons and in the quadratic lessons, there was always a question like that. There was always a question that said, which value in the sequence has this numerical value assigned to it? Now, you will be asked questions like that in geometric sequences, but what we need to just sort of take a little tangent, take a little journey down memory lane, is we need to just recap some basic exponential equations. Because when we do start to solve for which term in the sequence or which position does this term have, essentially what we're doing is we're solving an exponential equation. And exponential equations are really easy if you know what you're doing, but can trip us up with just some basics that we often forget. So before we jump into those sorts of questions, I just want us to recap some exponential equation basics, okay? When it comes to exponential equations, if you need more practice there, go back to your grade 11 notes, go look at past papers, they're all there. But just in terms of these sequences, we do need to have a basic understanding of our exponential equations. So we've got 5 examples. So I'm going to go through them relatively quickly just because we've been doing exponential equations essentially since grade 8. So this is nothing new. There's just a few reminders that we need. Okay, so if we have a look at question 1, we've got 2 to the power n equals 64. Now we know that when it comes to exponential equations, the trick or the rule or the steps that we should follow is make your bases the same. So we now need to figure out, how to write 64 as a base of 2 and some exponent. Now, I hope you all know how to do this on your calculator. I think we have had this conversation, but just in case, if we go and have a look at our calculator, which I'm obviously panicking about here. If you go and have a look at your calculator again, which I'm going to project onto the screen just so that you can see. So many buttons to push. Okay, so here's my calculator. We want to know how to write 64 essentially as a prime base or product of prime bases. Now, the way you do that is you type in the number you're looking for. So in this case, 64, and on your calculator, you push equals. What you then do is you want the prime factors. So if you have a look on your calculator, above the button that has like the commas and what looks like decimals, it says fact in yellow. So we will say shift and then fact. And what your calculator does is it automatically gives you the prime factors. So now I know that I can write 64 as 2 to the power 6. So that's just a useful trick to know. If you need me to explain it again, you can just let me know. I think most of you probably do know how to do this because you use it quite a lot in grade 9, grade 10. But if you don't and you need me to explain it again, obviously just ask. But prime factors on your calculator, honestly, is such a nice trick to have. Not all calculators are able to do it, which is a little bit annoying. But there are other ways that you can find prime factors. So remember, like the ladder method or the tree method, you can find your prime factors that way. But essentially what we've established is that that can be written as 2 to the power 6. And so when we solve this equation, my bases are the same. The only thing that now needs to be equal are my exponents in order for this equation to be true. And so I know that n is equal to 6. So like I said, that's a basic like grade 8 type equation. There's nothing super tricky there, but it is important that we know and understand how to do that. Now, this is important because if we now go and have a look at question B, you can see that question B is very, very similar to question A. The only difference now is my base. So I now have a base of -2 to the power of n. And what's really important here is that we remember that when we have even exponents, something quite special happens when it comes to the value of a base to an even exponent. So -2 to the power n is great, but 64 could also be written as -2 to the power of 6. And the reason for this is quite simple. I'm not going to do something to the power of 6, but the reason for this is quite simple. If I had -2 to the power of 2, that would be a -2 times a -2, which gives me +4. If I had +2 to the power of 2, that would be +2 times +2, which still gives me 4. And this goes back to our exponents when your teachers always tell you, if you are going to square root a value, remember your plus minus. So the square root of 4 actually has two potential solutions because we could either square a -2 or a +2 in order to end up with that same value 4. The same is not true with odd numbered exponents, because if it was to the power 3, you'd be multiplying 3 negatives, and so still end up with a negative. But when it comes to even exponents, your base could be a positive or a negative. So I'll just make a little note there in case that is helpful to you. So when we have an even exponent, the base could be positive or negative. Now that's obviously based on what you're given, so bear it in mind. So in this case, we used a negative base because the base I was working with the unknown exponent was negative. So we just need to be mindful of what it is we're working with. But that's something really important that we need to remember from our exponent laws and the exponents that we did grade 10 and grade 11. Okay, so if we have a look at question C, this is essentially exactly that idea. So question C, we've got 1/81 equals -1/3. So if you go and do the shift back thing of 81 on your calculator, you'll get the prime factors. Now the prime factors of 81, or if you wrote it as its prime factors, this is essentially 3 to the power of 4. So we could write that fraction as 1/3 to the power of 4. But remember, I'm dealing with a negative base on the other side. And so what that means is I could actually just have -1/3 to the power of 4 is equal to -1/3 to the power n. Because remember, the goal is to make the bases the same so that we can work with the exponents. This -1/3 to the power of 4 still gives me 1/81. Yes, it's negative, but because I'm saying a negative times a negative times a negative times a negative, I end up with a positive fraction in any case. So there's nothing wrong with that. And so we're able to then solve that n is equal to 4. All right, so that is sort of the crux of this. Please remember that when you've got that even exponent, your base could be positive or negative, and you will get the same outcome. And we need to remember that as we go along. All right, so what I want you guys to try for me is to solve for n in question D. You can go on to question E as well if you want, but I'm going to give you like a minute or two to solve for n in question D. Okay, this one is kind of testing how much you remember from your exponential equations. And again, if it's not much, that's absolutely fine. You just need to remember to go back to your grade 11 work and revise it. Okay, guys, let's have a look. So first thing that I want you to notice is that there's this coefficient of 2 here. Now, if we don't like it, divide it away. So if we divide both sides by 2, we end up with 1 over 256 is equal to negative a half to the power n. Now we have one term on either side. That coefficient is gone. It's not giving me a problem. I can go and solve for n. Remember, we want this 256 as prime factors. And so this could be written as 1 over 2 to the power 8, because 256 as prime factors is 2 to the power 8. But bear in mind you have that negative. We've got an even exponent, so that's not a problem. I've got negative a half to the power 8. That still gives me 1 over 256 is equal to negative a half to the power n. And so n is equal to 8. So always remember, when you have that even exponent, you could either be working with a negative or a positive base, and you will decide which is most appropriate based on what you have. Because I had a negative base on the right-hand side, it was more appropriate for me to use the negative a half. If I had a positive base on the right-hand side, it's more appropriate to use the positive a half. Both give me the same value, so it's not an issue. However, when you look at something like E, okay, now, if we go and write 1 over 32 as prime bases, this would be 1 over 2 to the power 5. Now, that is an odd exponent. When you've got an odd exponent, what you need to remember is that there's only one option. It's either going to be positive or it's going to be negative. And so we actually have a bit of a problem here because that is a negative base. If I had, negative a half to the power 5 to make those two bases the same, I'm going to get negative 1 over 32, but I'm not working with a negative, I'm working with a positive. And so, grade 12s. And so we need to bear in mind that this rule does not apply when it's odd exponent. So this is actually not possible. We can't solve this because of that odd exponent and the two different bases that we have. If it was even, we would have no problem whatsoever. So this is just something to bear in mind, and it might seem like such a silly thing, and oh, I do know this, but it's something to bear in mind because now when we look at our next example, it's going to be helpful for us. So just to reiterate what I've already said, if n is odd, so if your exponent is odd, there's one solution. If your exponent is even, there are two solutions, the positive or the negative option. Okay, and just bear it in mind as we move forward. So I'll leave that there for a second or two if you need to screenshot it, but let's actually put this into practice now in terms of our geometric sequences. Oh. Okay, so let's put this into practice. So we've all got our screenshots. And this is exactly what I was saying before we had a look at those exponential equations. We need to have that information in order to answer questions like this. Determine which term in the sequence 4, 12, 36, 108 is equal to or has a value of 8,748. All right, so if we want to do that, the first thing that we need is our general term. So Tn is equal to A times R to the power n minus 1. We obviously need to work out R. Now, it's fine if you just go and do R on the side of your working out. There's nothing wrong with that. It's all still there. And so R is T2 over T1, which is 3, because 12 divided by 4. That allows me to find Tn, which is 4 times 3 to the power n minus 1. Okay, so now that we've got that, we can easily go and work out which value is 8,748. We're going to substitute. Remember, what I'm giving you here is Tn. I'm giving you the value of the term. So that is going to mean 8,748 is equal to 4 times 3 to the power n minus 1. Now, we've just done an example very similar to this. We have a coefficient of 4. I don't really see its purpose. I can get rid of it. So I'm going to divide both sides by 4, because then I just have one base on my right-hand side, and that's not creating chaos. If I divide 8,748 by 4, I get 2,187. Got one term on the other side, no issues. Now what I want to do is I want to write that 2,187 as a prime base. You can use your calculator. Probably want to use the ladder method for this. Probably will take a little longer, but if you need to, go for it. But what we find is that 3 to the power 7 is equal to 3 to the power n minus 1. Now remember the basic rule of exponential equations. What we need to do is we need to get our bases the same. And once the bases are the same, we can equate the exponents. So now I can say 7 is equal to n minus 1, and I can go and solve for n. Right, obviously remember guys that once you have that equation, you can go check yourself. So if you're not 100% sure that what you've done is actually correct, do a check. So if you now go and say Tn is equal to 4 times 3 to the power 8 minus 1, make sure you actually get the 8,748. And just for sake of proving the point, I'm sorry, I'm being lazy. I'm not pulling up my calculator. If you have a look, I've substituted in, and there is 8,748. I've done it correctly. So I've got no issues there. I'm sorted. That's correct, which means that's correct. Use your substitution, use the information you have in order to go and double check your answers, especially in questions like this where it's easy and it's possible to do so. Right, great tools. Are there any questions? Otherwise, I'm going to let you take a screenshot and then you're going to try by yourselves. Again, I know you know exponential equations. I know you've been doing it for, what, 4 years now. I understand that, and you guys all know this. But it's just, when we start to introduce it into a new section, sometimes we forget those basics. So it's really important we do revise those. All right, so here is your you try question. There's no medium or hard here, it's just try it. Which term of the geometric sequence 2, 6, 18 is equal to 4,374? So I'll give you a few minutes, give it a try. Let's see what we come up with. Again, put your answers in the chat, it might help someone. I'm going to mute myself and not talk and disturb you. Obviously, grade 12s, if you do have questions, please just unmute and ask, or you can put it on the chat. I have got the chat open, I can see what's happening. And remember, guys, I have shown you how to check your answers, so you can check your answers while you wait to make sure that you do agree with yourself. Nice, guys. Keep answers coming through. Like I say, you might help someone. And if you do have questions, obviously just ask. Okay, guys, let's have a look. Seems like most of us are done. If you're not, don't stress. Just take a screenshot. All right, so exactly as all of you said, n equals 8. N equals 8 seems to be the answer of the day here. We first find R, right? Because that'll be the piece of information that we have to work out. You've got A, but once you have that, you can go and find your general formula or your nth term. Once you've got that, you equate it and you've set up for yourself an exponential equation. So guys, the one thing you need to remember is just whenever you have that coefficient there, you can divide it away. We would divide away a coefficient if we had 2x equals 6 in order to solve for x. Doesn't change just because it's an exponential equation. So divide it away, get your bases to be the same. My brain has just stopped. Get your bases to be the same. Use your calculator if you need to. And you get that n is equal to 8. Right, so guys, that is essentially geometric sequences. You have to be able to find the general term or the nth term. You have to be able to find the value of a term. So like we did earlier where I say determine the value of the 17th term. And you need to be able to find the position or which term will have a value of. Obviously, we can step it up and we can add complexity to it. But those are essentially the things that you need to be able to do. Much like with the arithmetic and the quadratic, you need to use the features of your sequence in order to answer questions. So we do have another formula that we're going to add to geometric and arithmetic sequences, which is the sum of formula, which is not something we've ever dealt with before. And we are going to do that as of Wednesday. But as long as you can do the basics, find your ratio, sub in, solve for an unknown, you're good when it comes to geometric. Alrighty, so just quickly on the chat, that is the YouTube channel that you can access the recordings of the lessons from. I know that sometimes we have connection issues and not necessarily can always make it and so on. So that is the YouTube link where you can access the videos. I will put the link on our Google Classroom. And with that being said, there again, the parent WhatsApp group for your parents to join to get all the information, and the Google Classroom for you guys to join where you'll get your quizzes, the YouTube link. I'm going to put links up there to past papers, formula sheets, all that sort of stuff will be there as like extra resources for you guys. So please make sure you do actually join the Google Classroom. I know it's still new, so I'm not rushing the situation just yet, but it will be very helpful for you. And like I say, I'm going to put a fair amount of resources up there for you, especially because June exams are not as far away as we think they are. So it's good to start getting a head start. Right, but I'm going to leave that there in case you still need to screenshot. If you don't need to screenshot, you are more than welcome to leave once you've got those links. But otherwise, I will see you guys on Wednesday when we will chat about the arithmetic sum formula. It's such a cool formula and there's so many cool questions we can ask on it. So it's very exciting.